Hi, and welcome to the Breastfeeding Medicine Podcast. I'm your co-host, Dr. Ann Eglash. I'm a clinical professor in the Department of Family Medicine at the University of Wisconsin School of Medicine and Public Health and a board-certified lactation consultant. This podcast is produced by the Institute for the Advancement of Breastfeeding and Lactation Education and is co-sponsored by the Academy of Breastfeeding Medicine. Hi, everyone. Welcome back to the Breastfeeding Medicine Podcast. Today, I have a special guest, and we're going to talk all about pumps. So please welcome our guest, Eva Nagy-Gannon. Eva has a master's degree in economics, and she worked as a project manager for large-scale European Union-funded projects for the majority of her career. Her breastfeeding journey with her first child brought along a complete change in her career as she was awarded a 2-year research and development funding to explore infants' suckling action. She's now the founder and CEO of Cala Devices, a Galway University spinout that created the Cala wearable manual breast pump that mimics suckling. So she is in Ireland. She's also the host of the Letdown podcast, which I love the name of, where she sits down with experts to explore how we as a society can help breastfeeding mothers reach the 6-month exclusive breastfeeding milestone. So welcome, Eva. Thanks for being here.
Hi, my pleasure, and thank you for having me.
Yeah, I'm super excited for our conversation today. So can you please tell us about yourself and how you got involved in this field? Because it seems like an unusual avenue.
Yeah, definitely. Yeah, so it all started really with my breastfeeding journey with my first child. I suppose many moms experience this as well, that your first breastfeeding journey has a lot of challenges. You have to figure out a lot of things. So it's many ups and downs involved. So it was the same for me. And one of the things that was really a challenging part for me is that I was never really able to use breast pumps. So I tried, experienced a lot of discomfort and pain, and I didn't see much milk for it. So I could only express drops of milk. And no matter how much I tried different flange sizes or try to do different inserts, different suckling patterns or different pumps, it just wasn't working. And the problem really was that that it sort of set a doubt in my head about my breastfeeding abilities as well. So I was thinking of, hang on, if I don't see any milk in the bottle, then how much is my baby getting really? So it was really an uncomfortable place to be. And so as I was researching and looking at pumps and what could I use, somebody was posting on the Facebook group a video of a baby an infant suckling. It was an ultrasound video of an infant suckling. And I looked at it, I remember looking at it and thinking, okay, this is nothing what my breast pump is doing. It's just, that's not what the pump is doing.
Yeah.
So up until that point, I never even considered what's going on inside my baby's mouth, right? I could just see his cute face and that was enough. And and that sort of put me on a journey that got me here, although I never considered it would. But this is how far we got with this, because we started to look into it with my husband. He's in medical devices. And we were like, yeah, so what's going on with the pumps? Why are they so different? What's going on here? And that we did a small kind of testing principle. How would it look like if it would incorporate suckling? And we got a little proof of concept through a small research fund. And then the University of Galway picked it up for a 2-year proper research and development award or funding, where we had access to labs, resources, experts, engineers, lactation consultants, the Galway hospital staff. So it was a great environment to do a proper research and a proper development of a suckling technology.
Interesting. Yeah. It does take a team, right? To find that medical device person, and you just had that person in your own home. So that's phenomenal.
Yeah, that was very fortunate. We wouldn't have got it up to the university if it wasn't for him.
Yeah.
right? Like as a mom myself, I would just kind of curious about it, but he was the one from the sidelines kind of giving me tips and advice, like, oh yeah, let's explore that part. And yeah, so it was very important for him to be in the picture in the early days.
Yeah, kind of like a dream team. That's awesome. So let's talk a little bit about why, how or why babies suck so much differently than the pump,
Yeah, well, the short answer is that they have a tongue and
right?
pumps don't. It's so hinging. Everything hinges really on the suckling tongue, and that is just non-existent in breast pumps. So
Right.
breast pumps are simple sucking machines. They are like a vacuum pressure technology that generate vacuum, and by the law of physics, suck the fluid, the most mobile part of that setup out, which is the milk, suck it out, and of the compensation. They would have a few different inserts to make it kind of less painful or less rigid in connection with your breast. But that's basically it. It's a sucking
Right.
device.
Right.
And then the babies have a tongue that is a super agile organ that is capable for really complex motions, and it's in direct physical interaction with the breast. And that's huge. And if you just want to understand how significant that is, that the complex motion is present, is that you can just think of the effects of a tongue tie,
Yes.
how
Right.
much it compromises breastfeeding.
Right.
That kind of gives an indication of like how super important it is that all of that motions are there and present to get the actual optimal breastfeeding success.
Right. Absolutely. Yeah. Um, so there has been like sort of like the war of two countries in terms of looking at suck dynamics in infants and some controversy regarding the role of the tongue. Because I think that, if I'm not mistaken, some of the research out of Australia has indicated that it's largely vacuum that babies generate, that that plays a role in milk removal. Whereas I think Woolridge in the UK in the past has oftentimes said, no, the peristalsis of the tongue plays an important role. Can
Yeah.
you? Yeah.
Yeah, definitely. There is these two schools. You can call it two schools, although there has been changes over the time. So you have to see when those researches were really done. Like time plays a role here. Like, is it stripping the milk? Is it the vacuum? Is it the compression? Is it which one of these are? And to completely understand it, I suppose the best way to look at it is that there are 5 key actions that the tongue delivers. Obviously, because of the setup of the baby's mouth and internal cavity and all of that, it kind of looks like it's a peristaltic motion from the side.
Yeah.
But of course, the side of the tongue plays a role as well. It's not just the peristaltic motion, but other actions going on. So it's important to understand the function of these different parts. The anterior tongue, what does the anterior tongue move? What does the posterior tongue do? And 5 key actions need to be present for successful breastfeeding. One of them is the latch, a compression, but it's important where and how that compression is. The positioning, the what goes where, what the areola, the nipple, where do they position within the internal cavity? The sequence of the motions, the vacuum, and that's it. That's 5.
Right. Yeah.
So as you can see, vacuum is one of them. So vacuum needs to be there for to remove the milk. That's true. That and there has to be a certain degree of vacuum. So like if it's a low level vacuum, that's going to be an issue.
Right.
But you cannot disregard the other 4, and they're just as equally important. And I think I can refer back to the tongue tie again, like the babies who have difficulties with the anterior part of their tongues. So they're compromised with the latch, they're compromised with the compression. That hugely affects the success of the breastfeeding. So yeah, so both sides are true. So yeah, and we know that pure hand expression exists as well, and it's possible to express
Right.
some level of milk that
Right.
way. So yeah, compression plays a role and vacuum plays a role as well.
Yeah. So, so when I looked at the research on vacuum for infants, some of the research is done with babies, where they put, the pressure transducers on whatever device they're sucking on. And a lot of that research is like sucking on pacifiers, which is, non-nutritive sucking, which obviously babies do for a short time at the breast or towards the end of feeding or whatever. But in terms of milk removal, the understanding the vacuum that babies typically generate, there's not a lot of data. Like and it's really old. Not a lot of recent data. Although what I try to do, and you can tell me what you think about this, is when I look at new pumps, because here in the United States we have a gazillion million pumps, and so when a new one comes out, I try to get a sample, or when my patient brings it in, I use my gauge. I usually try to tell people to pump somewhere between 175 or 150, I should say 150 to 190 to 100 millimeters of mercury in order to mimic babies on average. But sometimes babies only suck at some of the studies show that they only generate 90 millimeters of mercury. So what's your take on the research?
Yeah, exactly. Actually, when you were bringing this up, I was thinking, oh, what is research that you looked at? Was it with a pacifier or a bottle?
Right.
Because most of the research would be from that, right? So that's where there is a commercial sort of agenda out there. So there would be more funding to research that. You would find less research on actual breastfeeding vacuum levels related to breastfeeding.
Yeah.
So yeah, we came to the same conclusion as well, that based on the research data, and we analyzed over 120 research articles on this, 190 would be the max that the infant is doing. Okay, occasionally they would go higher, but they would pretty much max out on 190. And even at lower level, they are successful. While pumps go over 200, 220 is kind of expected. 200 above 250 would be hospital grade. Millimeter mercury, of course, as you mentioned. And yeah, I suppose what we found again is that the pumps have to compensate for the lack of the tongue. So what the baby is able to do with its tongue to trigger the correct biochemical responses, the release, the secretion of oxytocin and prolactin, is what is needed for successful breastfeeding. So if you have that, a much lower vacuum level will be enough to remove the milk, right? If you just think of how you hear a baby crying, and moms often go into letdown just based on that, purely from the emotional hormonal reaction to that. So yeah, and then pump compensate with higher vacuum pressure.
Right.
But of course, yeah, that's not ideal, because higher vacuum pressure is even more likely to cause discomfort and pain. And that triggers a different biochemical response, adrenaline, to decrease the sensitivity to pain. So puts the moms on a completely different biochemical track.
Right. Well, the other thing I noticed with a lot of the pumps, and again, we have so many inexpensive pumps here, but even some of the more expensive pumps, if you can't control the cycle, like how fast it goes, as you increase the vacuum on these pumps, they slow. That can cause injury, right? Because you get low blood flow to the tip. So, and you're also creating more vacuum in those capillaries, which can cause a hickey if you do that to your arm.
Yeah.
And so I don't know if that word hickey is the same in Ireland as it is here, but
it is. Hickey exists here.
Like hickey sucking. Whereas if it's super, super fast, it would be hard. The vacuum just breaks so quickly that you can't get any milk removal. And then of course everyone's responds differently to different vacuums, right? But babies don't. When you look at the cycle that when babies suck, they don't have a prolongation of that vacuum, right? They're sucking, from what I can see from the literature, somewhere between 60 to 120 times a minute, depending if they're nutritive or non-nutritive.
Yeah, yeah. Yeah, yeah, it's true. It's true. It's an interesting, and I would love to see a lot of research, more research done on that, exactly like how the prolonged vacuum affects the tissue, the breast tissue. Like that was coming up a lot during our research as well. Like how would that affect it? Like there was considerations of one of our experts, medical experts, was suggesting that if you apply that really strong vacuum for a prolonged period, but I will have to add something to this as well. Uh, how does that lock also the lactiferous ducts, right? So the lactiferous duct itself is such a delicate pipe of the tissue. If you apply sudden vacuum pressure, like if the same way if you have like a balloon blown up and suddenly suck it, then it closes, right?
Yes.
So does that affect engorged nipple, engorged breast? Could that cause that? But these are all question marks, obviously, because there is no research going into this. But what I wanted to add here is more so than the prolonged vacuum, the bigger issue that is likely to be is that pumps work on whatever rhythm they apply, the vacuum range, the jump itself from 0 to 220, back to 0 to 220, that really sudden pressure on the breast, that could be a bigger of an issue, bigger issue. And that is something that it's not present in the infant interoral cavity. Now we are going into a little bit of like proprietary information that came out of the research, but the infants do oscillate differently in a much more gentle and nuanced way compared to pumps' sudden increase and sudden drop of vacuum pressure.
Yes.
And that's where we actually assume bigger issues in that massive range, as opposed to massive sudden range, as opposed to the fact of how long it is prolonged or how fast it is or how short it is. Yeah.
And also, when I look at some of the very few studies that are out there on vacuum, they vary. Like every second is a little bit different vacuum. They don't do the exact same vacuum every time, like an autonomous.
Yeah, no, they oscillated. They
Yeah.
oscillated. But obviously the babies have an immediate feedback to go from. So they have the immediate feedback of the flow of the milk that
Right.
they can respond to. So they have that going for them.
Right, exactly. And that kind of segues into, you had mentioned something about like this really rapid escalation of vacuum. It seems like it's, there's all these different ways that the cycles are shaped. So some of the pumps have a sort of a tiered approach to increasing vacuum, where it's
Yeah.
and others are like, and others are some are slower in the rise. And so, yeah, and I think this is one of the reasons, this and several other things, but I think the way the cycle is and how fast it is plays a really important role in why we can't say there's one best pump for all women, right? Because people respond differently to different stimuli. Just like we know oxytocin is secreted from all kinds of stimuli. You can hear, see, smell, touch your baby. You think about your baby and get an oxytocin release. But for some people, feeling the baby may not do it. It may need to be smelling, or it may need to be just touch and not hearing, And so we have different triggers. And with pumps too, like you said, you couldn't get any milk out of the pump. And the question is like, are people's bodies going to respond to one type of pump versus another? We can't determine that.
I suppose that was one of the reasons why we wanted to go back to how nature does it. I mean, we're talking about a method that has been perfected over millions of years, and it was a matter of life and death, whether it's perfect or not, right? It had to be something that works for everyone, really, for the baby and for the mom. So that's why we thought, no matter what, no matter how we can tweak pumps to be better, because I'm sure there is ways, and like things like the wearable pumps is brilliant from practicality perspective, but the fundamentals, we thought we have to go back to how nature does it and look at it and understand it and replicate it. Then we definitely improve something, right? As opposed to the pumps that was coming from a different perspective of just like, here's a machine that works with liquids when we need to pump liquid from one place to another.
Yeah.
And it works here too, right? So that was pretty much the consideration there. But yeah, following nature would definitely improve the situation.
Yeah. And then looking back at, some of like the history of medicine and lactation in education that gets incorporated into that was incorporated or identified, or somehow physicians learned about breastfeeding, back around the early 1900s, it was mostly midwives who were working with, moms, and there were wet nurses, of course, for people who had difficulty nursing. But that industrial revolution around, 1890, after the Chicago World Fair, and, with people going to factories for work, physicians were, they saw these babies die, and they needed something, but they didn't really, there wasn't like a science of lactation like there was the science of cardiology or the science of endocrinology prior to that, right? And so they were kind of stuck not knowing anything really about lactation, just knowing that babies were more likely to survive if they got breast milk. And so then they realized, okay, we'll come up with something else that babies won't die from. So we won't give them cow's milk, we'll give them this formula stuff that, okay, these babies are not dying, but it's obviously an inferior product, right? But then it kind of stopped there, right? So physicians didn't have to really understand lactation very well, because then they had this other food they could give babies. So it wasn't the greatest, but it was like, okay, well, they're surviving. It's kind of like the whole medical field, its approach to nutrition, which is like, it doesn't have much to do with medicine, unfortunately. And we still see that today, that, now with the study of the gut microbiome and the importance of prebiotics, I think physicians are starting to understand, wait, we are what we eat, and it does make a difference. But, I think that has been a big disservice to this whole field of lactation, maintaining lactation, pump designs, if there had been some robust, research or interest among physicians before 1900.
Exactly. It's as you say, it has more historic circumstances than any other thing that define that this is the way it is. And it was good at that time, and it was great that there is something. And by the time ultrasound imaging came along, that could have changed, it was in the position to change the situation and give more understanding on what actually is going on. By the time the board was set for the sucking device, and once manufacturers kind of settle into that technology and there is no alternative idea around, then it's extremely hard to make a move any other direction then.
Right.
So, and as you say, like the formula didn't help in that sense, that it was also an alternative that is taken away from the need to research the lactation further.
Yes, I think so.
So I think it was the matter of unfortunate circumstances that led us here, and then there is no direct motivation for any of the big players to step out of this.
Right. Yeah, I totally agree. And then if you look at the dairy industry, so I live and work in Wisconsin, and this is the dairy state in the United States. And so there's cows all over the place, and we have the Dairy Expo. The World Dairy Expo is in our town every year, and the science behind milk extraction from cows is like so incredibly superior to any doesn't come close, the extraction research for human milk doesn't even come close to the dairy industry.
Oh, I have an interesting information here. I had recently a person who's an expert in this field as well. I had a chat with her. They are currently researching mastitis in women, and she said they were digging out research papers on this, and she said that we found over 1,000 research papers on mastitis in cows,
Yes.
and about 100 about mastitis in women.
Yes, and yeah, totally. Yeah. In fact, one of the world experts in mastitis was here in Wisconsin for a long time. And she had people come from all the world as fellows to, learn about mastitis. And but, it's such a different, we have a mammary biologist here in animal sciences at the University of Wisconsin, Dr. Hernandez, and she will say, the cow's not really a very great model for human lactation anyway. But a lot of the research that we point to understand about human lactation does come from bovine and mice. And she said mice also are not a great model. Like pigs are actually the best model to learn from for human lactation. But we should be humans, right?
Yeah, but that's the thing, you see, like research is dependent on the commercial aspect, right? Yeah. So that's the unfortunate thing again in this case, that and that's why we see a lot of research in bottle feeding and how infants are reacting to bottles, because there is a commercial incentive behind that, but there is zero behind the actual suckling and the physiology of suckling, because the entire breast pump industry is set with the sucking device, the pump.
Right. So, although I think that people are smarter and they're more savvy, and pumps are here to stay in the United States for sure, because of the fact that we go back to work so early, and the wearable pumps have totally taken off. I think that there also has to be legislation about the quality of these pumps. So some people have brought in like very, very cheap wearable pumps, $20 pumps to me, and they are. It's insane how much of a violation it is to these people who are just trying to provide milk for their babies at work, and they're low-income women, and they're using these pumps that are just destroying, causing infection, causing edema, lowering milk production, because there's no control over this kind of thing.
Yeah, I agree with you. I was coming to the same conclusion that there must be something set up around this, because they do cause injuries. Just, generally what happens is if something is too painful, mom just stops that and just tries a different pump. So there is no real kind of control or real data collected on what exactly those. So it's more anecdotal what we know about what injuries that they cause. And of course, there is big question marks around what we were just talking about, the lactiferous ducts. How does that affect that? If you don't apply the vacuum in the right sequencing, then how does that affect things like the lactiferous duct, engorgement, all of those things? There is no real research on that one. To some extent there is, but not enough.
Right. And clinically, what I would say is that as I've learned so much more about pumps, and we have our new mastitis spectrum protocol out through the Academy of Breastfeeding Medicine, I've really come to understand how we have to work so hard with people who are having recurrent plug ducts, and who are exclusive pumpers, which is very common here, especially in the preemie population, that we can figure it out, that we can figure out that I can see where there's just recurrent areas of edema related to more production relative to milk removal. And that's really, I call it having the Instant Pot bubble over, or having the pressure cooker bubbling over, when that's really and essentially what a plug duct is just edema. It's not a plug in a duct. And that edema is coming from just difficulty with milk removal, and that's coming from their response to the pump. And by tweaking, whether it's the cycle, the vacuum, the flange, their pump setup, with bra support or whatever, we can generally overcome that. And we don't have to have people struggling with recurrent inflammatory and infectious mastitis and recurrent plugs and the whole bit. Like, it's really just a matter of milk removal and figuring out what works best. But and that's why this should be legislated, because people are suffering. It's, you know, it's, we talk about injury, we think about like, oh, the nipples are sore, or there's a crack in the nipple from pumping, or there's some pain. But literally these recurrent plugs, this recurrent mastitis, these abscesses, those are all consequences of pumps not working well for people.
Yeah, exactly. I totally agree with that.
Yeah.
And then like things like, you know, we don't even have like good understanding of like when the pump is working, and we're talking about speed and the vacuum level of like what is there there for the infant. For example, the speed, right? We were chatting about that. The speed is defined by how big the interoral cavity of the infant is to start with, like how fast the milk is coming in. When its mouth is full, it's going to swallow. So its rhythm is defined by that. And pumps follow that. And I suppose this is something that they can really say, yes, we are like the infant is suckling, or we follow the pattern, the rhythm of the suckling, because we cannot do the same speed, or we are able to do the same speed. But the question remains, the speed really is there because the infant has a limitation of how much milk it can take in at a time. So is it really a necessary thing to follow that rhythm, or is there a better one for your breast? Right? So these are all very researchable and very necessary points. And I think in our previous discussion, you mentioned a pump that is like doing some really fast, really frequent stimulation. And you said, oh, there's no way that a baby could do that fast of a stimulation. But again, it might be something that is positive for the breast. Maybe there is no say, oh, this is just, if it's faster, it doesn't do anything. Maybe if it is faster, it's the better. And it will give you a quicker letdown if it's like 200 cycle per minute, right? Which is not something an infant can do, but it still might be your body is working in a way, or a human body is working in a way that, yes, it will create a faster letdown. So these are things that needs to be researched. It's like, if we follow any pattern and any function that the baby is doing, we need to understand that function, as opposed to just mimic it by how it looks, right? If we just say, we just mimic the speed of the suckling, that might not be the best way, because that's based on a limitation that it's only true for the infant. So
that is such a great point, because this particular pump that I was talking about, many people like it, and it's going like 220 cycles per minute, and I'm shocked at how many people really like it. So that's such a point, that we shouldn't just assume that the pump needs to mimic the baby in order for the mom or the parent to remove milk well. I love that.
Exactly. And that we need to be able to identify that which are the functions that needs to be mimicked, because they are for the breast, and which are that's only there for the infant. Like, say, some of the pumps incorporate the pause, right? So the pause, but the pause is only there because the infant needs to take a breath, right? So it's like, that's for the infant. And then at the same time, you see some TikTok videos of moms using a manual pump that she just kind of pushes down on the lever, and milk just flows. There is no break. It's like, it's super fast, efficient, because again, that rhythmical cycle is not necessary for her breast, right? So that because that's for the infant, the limitation of the baby's interoral cavity. So yeah, this is why it is interesting, and this is why we also in our research didn't just go like, let's just mimic how it looks, let's just go with the peristaltic motion as it is, because you need to understand exactly what the functions are and what is the purpose of those functions, and which functions are there for the infant and which functions are there for the mom's breast to provide.
Yeah, that's interesting, because one of the things that when I have someone who has low milk production, I obviously, and they're exclusive pumpers or relying on a pump quite a bit, I have them come in to kind of look at what's going on with that pump. But
I mean, I do think that low vacuum is a big thing for people. I mean, even, so I would be worried, when we talk about like, okay, let's look at what factors are important for mom and not necessarily rely on what the babies are doing. If babies are typically generating between like 90 and 190 millimeters of mercury, I really would not encourage someone to sit at like a 50 or a 40 or a 30 millimeters mercury to express milk, because they may, in the first couple of weeks, get a pretty heavy letdown with that because they're living under letdown, their prolactin's high. But over time, I suspect that they may drop production. And also, it may be that they can't tolerate a higher vacuum because they're using the wrong size flange. So they use a really large flange, they use a small vacuum or low vacuum, and they say, oh, I'm comfortable, but they, in the long run, it may not be sustainable for them.
Exactly. Yeah, like it happens a lot that because the pain and discomfort is too high at over, I don't know, 150 millimeter mercury, moms set it at a lower setting where they can still bear the discomfort, and then they end up not being able to express as much as they need to express, because at that lower, the vacuum is necessary. So you have to reach a certain level of vacuum for the milk to actually come out. Yeah. I had another thought there, but I can't think of what it was.
Okay. Well, when I think about, so I think maybe we'll wrap up a bit. I have two questions for you. One is, what do you think are ideal features of a pump, or features of an ideal pump, I should say? And then I want to talk a little bit, well, we already kind of talked about the limitations of pump research. So I think, maybe we can see if you have any more things to add about that. But what about, like, if I know you design a pump, so I don't, we're not talking about your product. We're not, and don't want to ask any proprietary, information. But obviously you sought to design a pump that is different than what's out there, identifying the limitations. And so what would you say if you were to give advice to someone who is developing a pump, another pump company? What would you advise that pump company?
Yeah, it's well, for myself, like I am on the mission to kind of put the physiology and the mechanics of suckling back into the center. I think that's the fundamental, most important thing about pumps at the moment, because we do see good innovation for practicality features, which I really love. Like, I'm a big fan of the wearable pumps, obviously. And you see like this development of the last few years of the smart functions, that I suppose that's super basic now as well. With pumps that you would have the smart functions. And I'm a little bit kind of torn with that, because I see that for moms, we tend to be very hyper focused on details when it comes to breastfeeding and pumping. And that's not necessarily as good as it might seem, right? Because if I would need to suggest something in an app for the breast pump, it would be that it has one big sign saying, "Mama, you're doing fine," as opposed to all the other details, because that's what we really need. But I know that's not where the gadget world is taking us.
Yeah.
I was thinking about it when you mentioned this, like what other features would be interesting to have. What I would love to see is a some sort of option where it helps you regulate your milk supply. So it I think it's very important to stay in tune with your baby. Low milk supply, high milk supply. So if you have an oversupply, I think that might not be as good as it might seem. So I would love to see some sort of option where you can say, include your baby's age or your baby's weight. So there would be an approximation of how much milk is necessary for that infant to take in at a time. So your pump could have, or your app could have, like a feedback to say, yeah, pump at about this much and not more, because if you keep pumping more out, you will put yourself into oversupply. And if you put yourself into oversupply, maybe that's not too bad, but again, research is needed on this because, the milk at the start of the feeding session is more watery. And
Right.
towards the end, that's where more nutrition tend to be, like the fat content and all of that comes in then. So what happens if you feed your baby, you have an oversupply, and you feed your baby from that, as opposed to a supply that is more or less in tune with what your baby needs? Then you might end up giving more watery milk compared to more nutritious milk. Now, this is again more of an area to be researched, but that would be a direction that I would love to go to.
Yeah, it's 10 to 15% of my breastfeeding medicine clinic dealing with overproduction and infant side effects.
Yeah, it's a thing.
Yeah, and I think the thing, that's interesting because when people are excessively pumping, what they do is here in my region, they will put on their wearable, their hands-free pump, turn on the pump, push it for 30 minutes and say, okay, 30 minutes, and then go do something else for 30 minutes, sitting, if they can move around, it's great. But they, and then there may not be milk flowing for the last 15 minutes, but they're, eventually going to raise that production. And so, having, like, when the milk starts to slow down for someone who has overproduction, to teach them, like, okay, the rate of milk production slowing, time to stop. Because that's the kind of information I give to people when we're trying to downregulate, when they're pumping too much milk. We talk about reducing minutes versus watching the flow and seeing when the fast flow is over and it's just, fast drip, stop at that point and make sure you best feel comfortable. And if the pump could tell them that would be amazing. But I think low tech is a good thing too, because, most people can't afford super expensive pumps. And when you start to put fancy things in there, you're not going to reach the people who have the lowest breastfeeding rates.
Yeah, I agree.
Affordable is super important. Yeah.
Affordable. And I would go with the same as well, of like just something that is very simple to operate, like the Medela. I always liked about the Medela pumps that you have like two big knobs that you can turn, and it's pretty much end of the chat. And it really worked on my mind. I remember when I was like breastfeeding my first one, and I didn't even know what's going on in the world. It's so overwhelming those first few weeks that you don't need complicated stuff. You just need super basic things that you don't have to put too much effort in figuring out how it works or how to set it up or how this and that. Just put it on, press a button, end of chat. So that's something that I think I would appreciate more. So I don't think we need to overcomplicate things.
Yeah. Great. Anything else you want to add, just to kind of wrap it up?
I just remembered what I wanted to say earlier about the feedback inhibitor of lactation, like that this is something as well that it's present towards the end of the feed. So if you leave that in the breast, that's kind of downgrades the milk supply. So that's again something that I know it's currently not possible to have that sort of separation and have understanding, but as you say, as towards the end of a pumping session, if you leave that milk in, that leaves the feedback inhibitor lactation protein inside your breast, and then that will gradually downgrade the milk supply. So that something, an additional sort of tweak in the breast pumps, that would help, I think, moms to be able to downgrade the milk supply. Same way if your baby stops feeding, so that maybe that separation is too abrupt and you want to gradually decrease your milk supply as opposed to suddenly stop completely, and the risk of having engorged breasts and stuff. So to have that you don't completely express milk, but leave the last quarter or something in, and then gradually decrease the milk supply.
Yeah, I just want to kind of make one kind of scientific sort of correction there. The feedback inhibitor of lactation protein does not actually exist. And the research on the feedback inhibitor of lactation has really evolved. It's actually not known. We know lactose, and there's been some good research in the last couple of years that lactose is a feedback inhibitor of lactation. serotonin as a feedback, but there are many bioactive factors that actually feed back to the cell. So there's not just that one protein. That there was a one protein hypothesis back in the late 90s, and that's been debunked. So
Right. Okay.
yeah, we don't have that anymore. But leaving milk behind is important for a feedback inhibitor. Yes.
Yeah.
Yeah. Well, thank you so much. That was awesome. It's such a great discussion. It's hard to find people who have really dug into this whole, the pump research and really understanding what's going on. And I think this is an area of just maternal child health, justice in health, where we do need to have policy that protects women from lousy equipment. And I look forward to more conversations with you, Eva, over time.
That would be lovely, Anne. Thank you so much for having me.
Yeah, take care. Okay.
Thank you.
Yeah, bye.
Bye.
For questions regarding this podcast, please contact us through our website at lacted.org. We have other educational projects, including the Clinical Question of the Week, our Little Green Book of Breastfeeding Management for Physicians, and our various educational courses and conferences for physicians and other breastfeeding supporters. If you want to see what we look like, check out our Breastfeeding Medicine podcast Facebook page, where you can post any questions or comments about our podcasts. Thanks for listening, and we'll be back with you in about 4 weeks.